Yeah, I thought Anya would be on for sure, but
Yeah, I just saw her join the Slack, so hopefully she'll be joining this pretty quick. So I'll keep an eye on the participants list and admit anybody else who shows up.
so are you taking this thing over?
I don't know.
Yeah, I think it's a big job for
Mhm.
somebody to say I'm going to take it over, but it is only a couple weeks,
Yeah, yep. I'm
and I
almost
think
not really sure if there's Anya. If like TWIML is the best medium for it going forward, if we're mostly going to be working on a Kaggle, it almost might make sense to, I don't know, make a Kaggle team or something and then do more informal meetings. I don't know. But we can maybe discuss that over the Slack.
yeah, and that was one thing I was going to bring up too is that you know I think Henrique had shown a lot of interest, but he wasn't here last week,
Mhm.
and he had messaged me. It was because of the election, and I didn't know he was running for office, so what's to keep up with? It's going to be weeks before this is sorted out. But um, uh, I mean, there's only five of us, so you know, anybody who wants to contribute, like we can just merge teams or whatever,
Mhm.
and kind of get that. I think it's advantageous the way Kaggle is set up, though, that you merge late
Hmm.
because right now we can all kind of go our own paths and have our own submissions,
Oh yeah, because of the quote, the
the
quota.
quota. But once you merge, you get a different quota. So I think it might be advantageous for us to keep working like this. And as we move forward, you know, I think it's 13 days until you have to merge. So then at the very end, you know, on in 12 days, we merge and then like have one common, you know, I mean, I think we're pretty much common on what you did. So
All right, so consider this meeting officially started. How's everyone doing?
Hi guys.
Hello?
Very good.
really good.
Great.
So I started looking at the notebooks. I still don't understand half of it. Sorry.
For
Um,
the Kaggle or?
yeah, the Kaggle.
Hmm.
Kaggle one. Or is that our first topic, or are we talking about something else first?
Yeah, I think that's pretty much our only
Yeah. Okay.
topic, unless there's anything that anybody else wants to discuss.
I'm definitely anxious to get into the Kaggle deal and review how to make changes and stuff like that.
All right. So I've been waiting for a grid search thing that I put together to actually start working. And RK, it sounds like you've gotten the best score so far. Do you want to kick us off and talk through what you've been thinking of?
Yeah, sure. Yeah, I totally ripped you off in all aspects of as far as like I said before, that BCE flat metric is the loss is like that's where I was stuck and I couldn't move forward from there. Um, I will say, let me see.
Are we talking about just taking the existing code and clicking edit and then making changes? Because
No, no,
can we go over maybe the high level of exactly how Kaggle is set up? And because like I can click edit and I can actually make changes and then I can save my own. Is that what you're talking about?
oh yeah, from Daniels.
From what? Yeah. And
Yeah, from Daniels. Yeah,
do
yeah.
that
That
and
so
then
I had done my own thing, but I got stuck
oh.
and I got really good results, but they weren't believable. And he found that, so I was kind of cribbing off of, I forget the guy's name that Daniel had posted, a guy who used Fast.ai, but it was like a different version, maybe V1 or something, because his code didn't work for me. But looking at what he was doing in his approach, I was able to actually make some progress and get to a point where I could solve it and get like some results, right? But I was having this issue where my predictions weren't working, and it was because my loss was wrong. And so it's weird the way I never dug into it to see like exactly what went wrong, because Daniel had posted that, he had kind of figured things out. So I just went into his just to see if I could replicate what he was doing. And I don't think you really posted your score. You just posted where you ranked. And so when I looked at it, I was ranked quite a bit lower, but there was also more submissions at that point. So I think that between not like setting a random seed and things like that, I couldn't replicate exactly what you did.
But you just took his code and hit enter, shift enter right on through his code.
I did. I questioned some things and kind of poked at it a little bit.
Okay, because I just want to know, is that what we're talking about? Taking the existing code, hitting shift enter, making a little change where we think is appropriate.
Yeah.
Okay.
Yeah. So
there was a couple things. The first thing, I didn't understand exactly how he was doing his train test split, and so I played with like kind of my own version of that. I'm sorry, I call it train test, train validate split, right?
Well, using the
maybe I
random.
should just pull up my notebook and we can talk through it.
Either that or I have mine.
I got mine pulled up too, so.
Yeah.
Yeah. Is this visible?
Yeah, that's plenty. If anything, it's too big.
Okay. It's kind of lagging for whatever reason. Just going to go into the edit mode here. So yeah, then we can go through all of the steps of like using and submitting as well. Might be helpful.
Very helpful. Yeah.
Yeah, so this was just the very basic notebook that I put together that without any real attempt at optimizing anything or figuring out any of the hyperparameter tuning, my only goal of this was to figure out how to load the data using the Fast.ai system, run it through a learner, generate a submission, submit, get a score. So this is just sort of like a bare bones skeleton that we can build off from. So starting out, just imported the modules that I'm using, little introduction following chapter 9, blah, blah, blah. So I started this notebook from the challenge page. So if you go to the, I think it's the Lishmoa challenge, you can do like a new notebook. And when you do that, it'll come preloaded with the data in the input. So I didn't need to do like the Kaggle API or anything. It's just there. So then I can run the code to, get the data sets as pandas data frames. Yeah, after setting path as this input, just following the data over here.
Great.
So yeah, then just pre-processing the data. This was mostly following the example of other notebooks that I saw. It seems like the key steps here are just identifying which columns are continuous, which are categorical, which are the dependent variables. So the CP type, CP time, CP dose, categorical. Continuous, I just said all of the ones that aren't in the categorical ones and are not the ID. The dependent variables, everything in train targets, and that just gets the name of them. And then I added those to the training features data set because it wants everything to be in the same data frame. I guess I should run this as I go. Yeah, so you can see that by appending the dependent variables, we've ended up with a more columns than we started with. Makes sense. Yeah, so this was just looking at the very end of the data frame, so some of the last 5 columns, and you see that these are some of the targets. So that was just confirming that the code here did what I thought it did, which was, again, appending those dependent variables to the same data set. So here's where I think that you were talking about a minute ago, RK, where I was trying to set up the train test split. So basically what I was trying to do here is figure out how many rows should be in the training set.
80%.
Sorry?
Is it 80%?
Yes, yep.
Okay.
So that's just saying like, okay, so 80% of the number of rows is this. So then the indices, I'm just trying to remember exactly how I did this now, but using the NumPy random permutation.
It's almost like a shuffle.
Yeah,
Exactly.
Yeah, and that's the part I wasn't familiar with.
That's a good one.
Yeah, and so I kind of overlooked that, and I thought you were splitting it like a time series. And then once I kind of got into it, I was like, no, he is shuffling this.
Yep. That's the permutation randomly shuffles that big list. And then you just chop the list in 2 chunks.
Yep. Yep, that's exactly right.
Brilliant. Works.
Yeah, I mentioned that because it wasn't like intuitively obvious.
I had to actually bring up my notebook and hit like, what is dot shape? Oh, that's 19,000. Then I had to do question mark, tell me about permutation. The doc strings.
Yeah, I'm sure that there are better ways to do this too. It was just kind of one of those, like, I don't want to spend all of my time figuring out like this very solved problem of splitting data into training and test sets. So it worked.
That's why it's called fast.
Yeah. So just following the book on this, I didn't put a lot of thought into what should actually be here. I just did the fill missing, categorify, and normalize. If I recall, RK, there weren't actually missing values anyway. Is that correct?
Correct. Yeah.
So
there wasn't missing values. So I don't think it's necessary, but I think there might be something Fast.ai does on the prediction side where if there was a missing for something we couldn't see, that's why I included it as well.
Yeah. Yep. And then the data, can I make this go away? Yes. The data is, I loaded it using the tabular pandas method. So that's taking the big data set that we prepared, applying these transformations. Recall that above we specified the names of which columns were categorical, which ones were continuous, which ones were the dependent variables. So that's all information that we pass along. And then splits is what we defined up here. which is just a tuple with 2 lists of indices for the training and validation sets. So then we have we have data that we can work with in Fast.ai learners. And then we can access the training and validation. You see that we have 19,051 training examples, 4,763 validation examples. And we're also able to look at a few examples. So we have a data object that we can actually make use of. And
What
then
was normalized? When you chose normalize as a proc?
Yes.
What got normalized?
I think that applies to all of the continuous variables, but I did not
Correct.
look into exactly what transformation it applies.
Yeah,
Those-
no, that's exactly what it does.
Those aren't normalized. Those wouldn't normalize.
No,
Between the range of the whole range.
it's normalized by what's the equation? It's value minus mean divided by standard deviation. So it's not going to be
0 to 1 or anything like that. Okay. It takes the whole data set and normalizes it with that formula.
it normalizes every column, I
Right,
think,
right.
that way.
Okay. Got it.
Yeah.
I don't know that it has anything from column to column.
Right. Okay, great. Thank you.
So moving on from there, we can get our data loaders out of the data set, or out of the, I guess I don't actually know what kind of object this is off the top of my head, out of the tabular pandas object, I guess. So data loaders, and then I just, in this case, passed 512 as the batch size, but
Is that the first hyperparameter that we've come across? Is that batch size right there?
yes.
Okay.
So the next step, setting up our basic learner. So that's just the tabular learner. Pass the data loaders from here. Layers, I would call this the second hyperparameter to tune, or I don't know if that would really constitute a hyperparameter, as it is more the architecture in a way, but this is pretty close to what was used in the book. And then the key point here is using this BCE with logits loss flat, because this corresponds to the loss function that is judged in the competition. So we'll set that up. I did the learning rate finder.
I still struggle with this learning rate finder.
Yeah.
I don't know.
So I don't know, I picked something in this range and figured
like
that
if
was...
you, but if you pick, like you picked, I think 600, 300 or 600, 200 or something for your layers. But if you change that to 800, 400, you get a completely different answer.
Yep.
And if you pick 900, 500, you get a completely different answer. And so it's like, I don't know.
Well, like you said, that is architecture, and then the learning rate finder is only a little glimpse into, it's not really a parameter. It's obviously different.
I think that's the big thing that I'm trying to learn going through this competition is how do we systematically approach just design, like choosing all of these elements of the design of our learners. Because that's something that I don't think that the book addresses head on. It provides some suggestions for how to thoughtfully make these decisions in advance, but not really a framework for digging into it and improving them once you have your basic learner. So I'll just get this running. It should be pretty fast. So I'm just for the sake of demonstration, doing 5 epochs with, Oh, this is here, RK, because after I ran it the first time, my validation loss looked way too good to be true. And so I was like, what is my loss function and is it correct? I was like, that is not the loss function I'm supposed to be using.
Yeah, that helped me a ton.
Yeah. So now that we've specified it, it is the correct loss function, and you can look at this.
And I think this is telling, if you look at validation loss here, this is telling about how this competition is. Because if you look at the results of the top 1,000 people, they are literally decimal points, like 5 and 6 decimal points away from being the same number.
That's something that would be interesting to do, whether it's with random forest or even just like predicting 0 for everything. Like it's coming up with a good baseline, I guess, because it seems like most of these, it seems like the dependent variable is a pretty sparse matrix, not a lot of actual activations or whatever it is.
That's where I started thinking about like using the feature importance to get rid of some of these features that don't matter at all and train a model the same, like leave your 600, 300 or whatever it was, but train it on a much smaller set of features and try to get, you know, a better result.
Sure.
At a really high level, one of the things I saw a few notebooks do is get rid of all of the ones that were classified as vehicle, because none of those corresponded to any of the dependent variables.
Right.
I didn't look at how many that actually corresponded to or anything, but could be a start.
What do you mean by corresponded?
So all of the dependent variables were just zeros for that. So there were no.
Yeah, there was a note. There's a note in the actual problem that stated that when this function's value is this, it has no activation. I don't know,
I'm
Daniel,
realizing that I'm struggling to talk about this because I have very little understanding of the underlying problem.
I don't understand the problem at all either, but I've been back and forth on this multiple times. And if you do, you have the actual website pulled up with the problem statement?
I can get there.
What do you not understand about the problem?
Just the physics behind, like what I don't have any experience in this actual realm of science. So I mean, I'm attacking it from a data standpoint.
Obviously, there's methods of action that they can attribute certain drugs to.
Yeah, right here, if you look at this, so in that first under files, control perturbations have no MOAs. So that should tell you to throw all those out. But what I think happens is that there are control perturbations at different levels with other things that actually are predictive. But they tell you specifically that these perturbations.
What does that mean? Have no? I thought control. I thought that was a variable, a category.
Yeah, it is. I think it's saying that the dependent variable is just going to be 0, so indicating no MOA for all of the different MOA possibilities.
That have control perturbations.
Yeah. So with the way that the data set is structured, we have like what is it, 200 something targets, say like 250 targets that are all binary coded 0 or 1, based on whether that mechanism of action is present. And this is saying that those rows that are classified as control perturbations are all going to be marked 0 for the dependent variable. So all of those binary classifications of the MOAs are going to be 0.
So, so the CP type can either be CP vehicle or control vehicle. And if it's control vehicle, everything's 0.
Oh. Damn, that's weird.
Yeah, it's way weird. Like I said, I'm not an expert in this domain for sure.
Oh.
I should be. I worked in like pharmaceutical related data for a while, but it was more in the
And it, Daniel,
area
we're
of like,
counting on you here.
it was more in the area of like pharmacoeconomics than molecular stuff.
Trying to make that money.
Now I work for a nonprofit, so. Okay, so just quickly going through the rest of this. So I finally got a test set working. That was exciting for me. So I previously defined the test features. Just go back up there so that there's no doubt about what that is. That was just grabbing the test features CSV file and making a pandas data frame. So we take this and make a data loader out of that. So we take our existing data loaders and we use the test DL method, which applies all of the relevant transformations, I believe, or whatever it does, it makes it compatible and able to.
We're still seeing the Kaggle page, not your notebook for some reason.
I'm seeing a notebook.
I see the notebook.
Same here.
It looks like you might be lagging a little bit there, so it might be your internet connection or something.
Yep. Okay. Yep.
So is test underscore DL, is that a built-in function of?
Yes, that
Okay.
is, yeah, that's Fast.ai built-in function.
Okay.
So again, I didn't dig behind the scenes too much on exactly what this does, but it generally makes it so that our test features are compatible with the data loaders that we've made and make, you know, the model can then generate predictions on those. So just to confirm that this worked, yes, we have our test set here with no labels. Kind of, these look kind of in the normalized range to me, eyeballing it, but again, haven't looked into it. We do have, let's see, I guess that's control. Never mind. Okay, so next step is generating predictions. When you do get preds, it comes out with a tuple. So that's why we're doing 2 here, just to have the predictions themselves in one separate object. So yeah, it was 206 columns worth. So this is the size and type of our predictions. Now we want to make this a data frame with the appropriate type. I think that this is something that I largely followed the example of another notebook for. So when I did this originally, I ended up with a bunch of like nested torch objects. So I think making it as type float took care of that. So this gives us a data frame version of our predictions. That's not very good looking. So sort of the final step that we do is I took the sample submission, which does have all of the IDs that we need to submit. And I, let's see, basically just added the predictions that I generated up here. I don't know what this line does, but I saw it in a bunch of places. and the
I think that's
submission.
where it's dealing with. I assumed you wrote that because I didn't
Mhm.
dig through all the notebooks that you did. But this is where it's looking at that CP type as control vehicle and zeroing out all
Yeah.
those values.
Oh, yeah,
And
okay.
actually, yeah, it made predictions that
Yeah.
actually are
It made
invalid
predictions,
Mhm.
but this zeroes out all of those predictions.
because we're
That
told
makes
ahead of
sense.
time that they should be 0.
This is tricky.
That's
That's
weird.
tricky.
Yeah, that's
That's a trick that they put in. Yep.
Yeah, I spent some time looking at that line of code to figure out why it's doing that. That's where I went back to, oh,
no, I saw that one in I think 3 or 4 different notebooks and was like, not
That's
going to
interesting.
spend time figuring this specific thing out because I'm trying to work on a few other things, but it seems useful and the submission works. So
yeah. So your location of the test features
yeah,
of CP type equal to control vehicle, and then right. So that's your index,
mhm.
and then your dependent variables. It's setting all of them to 0.
Yep. Yeah, so run submission head here. So this is just to show what our submission looks like. So we have the IDs and we have all of our MOAs. And then final step, you save it to CSV. So an index equals false because otherwise you will end up with an additional column on the left with an index. In my earliest days of doing things with Kaggle, that caused me so much frustration trying to make submissions and
So
having
much.
this.
So much. A pandas all day with the index. Oh my God.
Yeah. So now you'll see that I have an output submissions.csv. Let's see. Sorry, I'm resizing things and probably shouldn't be.
I think it looks fun.
Okay. So what I'm going to do here is save a quick version, go to advanced settings and say save output.
This is one part that I got confused on too, is that it seemed like no matter what I did on the quick version, it wasn't enough to submit the CSV.
So I haven't actually tried this with a quick version, so it's very possible that this will not work. But
Okay.
I'll give it a
I
quick.
had to go to that full version and save that whole thing, which was the save and run all commit
Yeah.
is what I had to do to get mine to submit, but I could have had something else wrong.
Yeah. So then I'm gonna leave the editor. So now we're just doing the final step, which is actually submitting for scoring. I want to go to the most recent version, which is still finishing whatever compiling it's doing. A quick version. And we'll see if it's there. So to submit, you click on this little menu button here, go to submit to competition. And it does populate with my output file submission.csv. I'll just go ahead and do this because I have not actually made any submissions today. You hit submit, then you can go to view my submissions. And it'll come up with the submissions. Yeah, so the best public score I've gotten is 0.01998 so far. And then it takes a bit, I think it reruns the notebook or something. And
yeah, it runs
takes
through
a while.
everything again. It has to calculate all of your values and your predictions again, which is good because of the things we know about, how random everything happens. right? So this is one thing where I think we should get in the habit of setting a seed
Mhm.
at the beginning, whether we use the magical 42 or we use 0, I don't care. But I think that's the only way to get consistent results.
Yep, so that is the absolute bare bones process.
So you should be back here at this 021117.
Yeah, it should. Well, I think I might have just totally unsystematically changed a couple of the parameters since that initial run. So it might be closer to this one, the 0.02078, but yeah, I expect it to be in this range when it finishes.
Daniel, I think there's somebody who wants to be let in Slack.
Oh,
I just checked it.
participants. I don't see anyone in the participants list.
No, it says need host to let me in. Yuri or something.
Oh, shoot, that was a while ago.
Oh.
Oh, and it completed, and yep, it's the 0.02074, which the previous one where I think everything was the same was 0.02078, so very close.
So could you talk a little bit about where your improvements were between this V1 commit and V3? Is it just more epochs and smaller learning rate?
Yes, I think that was the first round of improvements I made. I'm actually interested to see if this has finished running. So just a second, your work.
So you're making your own grid search?
Yes.
Okay, yeah, that's what I wanted to do, but
Why are you doing that?
I haven't done any progress this week. I took a week off.
Good for you. Good for you.
Those
Yeah.
water skis were calling your name.
I'm water skiing last time tomorrow because it's really cold, but it's Veterans Day. That's the last day of the year.
Oh boy. You wear a wetsuit and everything?
I'm in a dry suit, but it's still freezing.
Oh yeah.
Yeah, it's like, it's my feet get so cold, but you know, that's my tradition. Second year.
Yeah. You should
And
water ski where Butch is in the Philippines.
What? Oh, we've been having storms here, actually.
Yeah, you can't water ski in that water. That would be more like surfing.
Yeah, the biggest storm in the Pacific just
Eta?
passed through us about 2 weeks ago.
Oh, it wasn't Eta, right? Because Eta is destroying.
And there's been like 2 storms since then that passed through. So
Golly.
it's been raining. So I'd rather probably be there with the snow coming up. I mean, I think it's starting fall in Tahoe.
Yep. Yeah, I'm in Seattle and we have snow in the mountains. So
Wow. Yeah.
I'm in North Carolina and it goes between a low of 32 and a high of 78 every couple days. So absolute chaos.
yeah, we have 30 at night and about 55 during the day.
Been 80 degrees in Louisville, Kentucky the last 3 days.
Nice.
Record breaking. Not nice. It's probably a climate problem.
Oh yeah, that is not nice. But it's nice to water ski in that temperature.
Absolutely. It's nice to do yard work when it's 80 degrees. Okay.
So Daniel, with your grid search, are you extending some class like SK Learn class, or are you making your own just manual?
I'll show you. It's mostly manual.
Okay.
It's something that I threw together. Oh, there's Yuri. Okay. Yeah, something that I threw together very quickly just to get it working. It's not an elegant solution by any means, but I will go through it. So I made just a new version of the notebook that I showed before to do some tweaking of different things. I started out just thinking about what parameters we can actually do anything with. So I'm thinking learning rate. I've had some success with weight decay. I haven't really done much with the model depth or with layer size. Batch size is one that we can tweak, and I found that it is pretty sensitive to the batch size. Momentum, I don't know anything about, but I know it's something that we can tweak. And then I've also read about trying to work with different weight initializations, but I don't know the process for that.
So can you scroll back up there? I just want to comment real quick. I've been playing. I've been studying learning rate, model depth, layer size, and batch size. And I feel like probably the learning rate with the number of epochs is a huge deal. The model depth has almost no improvement on this model. Like if you're talking about the number of layers, has almost no improvement. And then the layer size has a pretty large effect. And the batch size, like I said, seems like it's tuned in with learning rate and the epoch. Like there seems like there could be some relation there. I haven't messed with momentum or weight initialization.
Have you looked at weight decay at all?
I know of it, but I haven't messed with it on this problem.
I have found it to be like moderately sensitive to weight decay. So that might be one that's worth it. But anyway.
So Daniel, you don't want to include number of epochs as a hyperparameter?
If I meant to. Yeah, this is just I didn't add it to the list.
Okay, just asking.
And sort of my approach with the grid search, because of the way that Fast.ai recommends like retraining the whole model once you kind of get a better sense of the number of epochs, is to go pretty broad with the number of epochs, like even just let the model overfit, but record the best validation loss. And I'll show that. And then go in and like manually explore things using that number of epochs to try to zoom in on the best number, I guess.
Yeah, I agree with that. And also from what I saw, it seemed like no matter what I set everything else to, about 12 was the point where it seemed like it was going to start overfitting.
I was getting some that were closer to the 20-ish range, as you'll see. That might be because of using weight decay, though.
Yeah. Well, in mine, what I was looking at was the slope of my validation loss versus the slope of the training loss. And so as I saw the training loss keep getting better and better and better, but the validation loss like flattening out, that's where I got scared that I was overfitting.
Right. All right, so just getting to the loop. I started things out the same way, pulled the data files, pre-processed the data the same way, same divide of training and validation set. And then, yeah, getting to grid search. So the big thing is using the parameter grid function from scikit-learn's model selection submodule. So what this does is lets you pass a dictionary of the different parameter values that you want to try. So in this case, I did 2 different batch sizes, 3 different learning rates, 2 different epochs, 4 different weight decays. These were all reasonable values based on my manual testing, but the main purpose of this, as I just got it working earlier today, was testing the grid search function. So I'm looking forward to trying this out on a wider range of values in the coming days. But anyway, what this gives you so you first define this dictionary, like I said, and then you pass the dictionary to the parameter grid function. And then that gives you a Python iterator that you can use to like look at each individual combination. So when I do, the list comprehension X for X in grid, you can see all of the different combinations that this covers. So, 1024 batch size, different learning rates, different numbers of epochs, different weight decays, all the way on down. So this is 47 different combinations of hyperparameters. So I'll share this, but after we're done here. But this is kind of the major component of the grid search, is getting this parameter grid set up. This was me just messing with basic Python functions because, again, Python is not my native language. And then I defined a function called grid loop, which at its core is just a loop. So the only argument that I passed it is grid because I didn't make it modular for different learners or anything. It's, just the grid. An empty output list, names for what I actually want to display, because my main purpose in going through this is to collect a bunch of information about different combinations that I can then use to figure out which general areas I should be targeting for more manual investigation. And then the main loop. So grid is this object that I showed you before. And I say for P in grid, where P is going to correspond to one combination of the hyperparameters. So it's going to look at each combination of the hyperparameters, extract the learning rate, extract the batch size, extract the number of epochs, extract the weight decay. I don't actually need to initialize these as separate variables. I just chose to for ease of reading. Initiate the data loaders with the correct batch size. Initialize the learner. In this case, I did a 1,750 and 300 layers. Again, I haven't really figured out a system for checking those, though I will probably add them to the grid search and do a much longer one at some point. Loss function stays the same. Weight decay gets pulled from here. Do the fit one cycle with the number of epochs from up here and the learning rate from up here. Then I made like a temporary output object where my main goal is just building up a list of the data that I want to have saved once I'm done running the whole loop. So in this case, I grab the values from P. So I grab all of the different combinations because I want to be able to make sure that I've recorded which hyperparameter values correspond to which validation losses. I grab all of the losses. Now this is the part that's like very hacky and not a good way to do this, I'm quite sure, but I basically grab all of the losses, and over the course of these lines, I look for the validation loss that is the minimum. So I'm not just looking at the final one because there's a good chance that I've overfit and that my validation loss is getting worse. I'm just trying to find the best validation loss for each of these different combinations. I record that loss. I record the index of that loss so I know which epoch it occurred at. So I can start to maybe get a sense of the number of epochs that I should use. I append all of that information to the output list. And then finally, so this gets appended to this out list that's outside of the loop. So that's being built up as you run through each iteration of the loop. And then finally, the final output is a data frame of that output, which is a list of lists. So it turns into a data frame. Columns equal names. I define the names above. That's just saying what I recorded: batch size, learning rate, epochs, weight decay, the minimum validation loss, and the epoch number. So then I just copied the parameter grid from above. These are the values that I tested. Oh yeah, in this version, it also saved all of the output from that. I have a later version that suppressed that, but for now I'm just gonna scroll past that. This is the training results from every single one of those combinations, so there. And then the output that I get is this. So again, it shows all of the different hyperparameters that I was looking at, and also the minimum validation loss and the epoch at which it happened, which I was surprised to see. It was generally at the final epoch for most of them, with a few exceptions. I don't know, that doesn't match up super well with what I was seeing when I was running this manually. So I need to investigate that a little bit more. But it wasn't always true, so I'm thinking it was probably working right. But anyway, this gives us a lot of combinations of hyperparameters to look at to try to get a sense of what it's sensitive to and what we might want to try. So the best combinations that I got were these two, where I did 20 epochs, and apparently the minimum was at 20. A fairly large weight decay, yes. Fairly large weight decay, moderate learning rate, 1024 batch size. So I think that the next time I run this, I'm going to focus on things around that area and see if I can find something better from there. I haven't made a submission with this yet, but I will say that this is a better validation loss than I got on any of my prior runs. So I expect that that'll be better than my prior scores.
What is the 0500100 column? That 1, 2, 3, 4, 5th column. What is
This
that?
one?
Yeah.
This is weight decay.
Oh, that's the weight decay.
Yeah.
So that's what I haven't played with yet.
What's
Yeah,
the
and I was seeing decent variation based on weight decay, at least in my manual.
what's
Yeah.
the intuition behind weight decay? Just run me through the basics.
I don't remember exactly how it works mathematically, but I think it discourages very large weight values, which can lead to overfitting and possibly instability. So it, in my experience, just playing with this, it sort of lets you run the model for more epochs without overfitting.
Makes them smaller.
Yeah.
Yeah, I think a lot.
It encourages smaller weight values.
So it dampens kind of the activations.
Well, now you're going to make me really angry as a mechanical engineer, because dampen means to wet and damp means to.
All right.
Okay, so I'm just being an asshole. So, but it's one of those things where us mechanical engineers who have spent so many hours looking at damping, we haven't looked at dampening.
All right.
Okay,
I'm
but your intent is correct.
I'm a double E, so we don't.
But you have damping too. When do you ever put a water hose in your circuit?
Or put a resistor to damp the response.
Yeah, to damp the response. Yeah. But yeah, so
weight decay just makes things a little less unstable. maybe.
So it's like regularization, right?
Okay.
Exactly.
Yes.
Yeah.
That's good.
The things I have played with are batch size, which I've been using 1024, and got the best results there. Epochs, I haven't gone past 12 because of what I said before. And I think the biggest difference is probably the layer, the number of nodes in a layer. And what I found best was 1600 and 800 train the best. And anything, I went up to 2000 on the first, like kind of like up 400, and it didn't help. It didn't noticeably help. And then I tried going back and adding more layers of depth, and that also did not help. And the single biggest thing I did that helped, which is what I thought of this afternoon after having Jim Beam and Coke, and thinking about the numbers that you had posted, Daniel, about where you were, was that there's this idea that, especially with time series data, that you split your training and your validation, and you train and I'm sorry, I should say training and no, validation. Yeah, that's what we talk about in Fast.ai. You split those and you train, and then you do the validation, and then you save that model, and then you ship it off to be tested by this independent source. And what I was thinking of was, well, but we have this training data. So why aren't we using this? Even though we're randomly splitting it and everything else, we still have more. So let me use the split data to determine the number of epochs, the number of layers, the number of all these things. But at the end, before I submit it, I want to submit a set that is not split. I want to train on everything I have access to give my model everything else. And that's literally what moved me from 2812 to 2685. Huge difference. So I'd like to hear other people's thoughts on, like, am I crazy? Was I lucky? Is that?
No, I've done that before with other machine learning projects as well. Like after you do all of your selection and everything, like as a final step, retrain on all of the data you have access to and submit. I've seen arguments both ways for whether or not it's actually a good practice. I know that there are some schools of thought that it's like only use your training data for training and you risk this, that, or the other thing if you don't, but it does to improve
but
results.
in this case, I think I think that, and like I said, it's the single biggest knob that made a difference. I mean, I submitted, I think I have 4 submissions now. And everything I did with all the other stuff I talked about moved me from 3,078 to 2,849. I was right next to Anya. I actually saw her name in the thing. We were like right next to each other. And then I didn't know what else to do. I tried a bunch of stuff, and then I did that one thing, and it jumped me all the way to 2685 or whatever.
So for Kaggle, it's fine because we have this target, we want to improve the rank, but in real life, it's not a good approach because, you know, you may overfit without understanding. You know, you do need to fit to the validation set. Basically, you're using validation set to test how your training is going. And if I wanted to use the entire data set, I would use cross-validation because that's where you would use, you split your entire data set into folds. And every time you train on a different fold. So that's the approach that I was taught in classical machine learning. But deep learning is different. But still, in deep learning, I think we do need a validation set for fine-tuning your training.
Well, and I don't disagree with anything you've said.
Yeah.
Okay. I think there's two things that got me thinking about this. One is that in this case, it's almost like time series data. And this is the common practice in time series data, that you will train and study, you will split your set and study what works the best. And then at the end, before you release your model to production, you will train on the entire set. Because if you don't, you miss that whatever you, because you cut off the end part, right? And so if you don't train on that end part, how do you predict ahead of what just happened? And so
And why there is time series? Why do you think there's time series here? I didn't see any.
no, I don't.
Okay.
No, I'm using a leap of faith
Okay.
to justify that there's time series because I don't have their true validation set, their true test set.
Yeah.
Right? I don't have those results. So it's only time series because when I submit my results, I know that I don't have what they're going to apply it to.
But that's a good point. If there is some time series in here, then our split shouldn't be random. It should be more like Jeremy showed in the time series example, where he chose the last piece to be the validation piece.
No, there's I'm sorry, maybe I'm confusing this. There is no time series in this data.
Okay.
There's no time channel. So there's no way for us to, what I'm saying is the time is what they have that we don't have.
But I think Anna's point is that you can use cross-validation. And I saw a notebook
I
that
saw lots of notebooks that use CV.
Tabular
Lots and
Pandas
lots.
with cross-validation. So I think, well, if you want to just crib that and use cross-validation, I think it's a much better way rather than retraining the whole data and submitting it.
Well,
I don't know.
I don't have data to back this up, Butch, but like my experience so far with this data set in particular is, well, my experience with machine learning overall, cross-validation is a wonderful technique. And you're 100% right. What I'm saying is, even after you do cross-validation to choose all your hyperparameters, it seems like this data set might perform better if you included all of it as training. And that's a hypothesis. I'm not saying this is true. I'm not saying this is best practice. I'm just saying, of all the knobs I turned, that was the biggest one that worked.
Yeah, because we're in a competition setting. I just, because like I want to practice what I preach. So in my world, I just like, at work, I never do that. Because then what really matters is live results, right? So it doesn't matter how well I do on the test set. I can have wonderful results with my test set using cross-validation, but then live model just doesn't perform. And that's where I just established that practice. But yeah, like here we can risk anything here and just submit and get the higher and higher rank. But
and maybe we're not talking about the same thing, but like, so when we split this test set the way Daniel did, that is your training and
validation.
What you're calling validation.
Yes.
And we don't have access to test.
Correct.
So
But we get the score on the test, right?
you get the score, but you're not training on it.
Oh, yeah. And you never train on the test.
Right. But what I'm saying is that if you extrapolated to a time series standpoint, you don't know what's in the future. So you never have that test set ever. Like if you're modeling stock market, right? And I take up until today at, even if I go to 5 p.m. and include post-market data.
Yeah, because stock market is time series, yes.
Right. But for me to learn anything today about what I think is going to happen tomorrow, I need to train my hyperparameters up until 5 p.m. tonight. But I need to split the end of that off, like what he does for the bulldozer set. Split the end of that off. But then before I release that model for production for buying stocks tomorrow, I'm going to train all what I think are my best hyperparameters on the entirety of the data all the way through the end. And that's what I'm saying is kind of, it's not time series, but it sort of is.
What you're saying, RK, is basically you want all your data to determine the best model that you want to submit, right?
Correct.
Yeah.
Once I think I know something about those hyperparameters,
Yeah.
I need to split it up
And
to
I've seen that
study
debate.
epochs and things like that.
Yeah, I've seen that debate, even in Kaggle, that technique. And I guess it has to do with the volume of data available for training. Because in the reason why I think in Fast.ai, he doesn't focus too much on that, because the idea in deep learning is you should have lots of data. But here, I think to some extent, there's not a lot of data, given that you have so many things to predict and only so many things, and it's sparse. The data itself, the output data, is pretty sparse, right?
Yeah,
And
I agree. I agree with that.
so it does make sense to try to use all of the data to make a prediction. But I would still agree with Anya that I think the best way to do it is to use cross-validation. So I'm seeing this guy. There's this Fast AI guy, Kerem Turgutlu, who's, I think, one of the, at least 1,000 times better than me, because I've seen him in other competitions. And I saw his notebook, and he's using cross-validation to
what kind of learner?
best model.
What model?
I think he's using fivefold cross-validation, and he's using that to submit. And I think he got better results. He's, I think, in the thousands level. The other thing is that, remember, there's this surprise that a lot of people get when they try to do this, where they submit, they basically train on the whole data, and then they get good results on the public leaderboard. But then once the private leaderboard goes up, the people who followed like the best practices in terms of doing cross-validation instead of retraining on the whole data, they usually end up with a better predictor of what their performance will be on the private leaderboard. Because remember, in this data set, I think there's a very large gap between what's in the public leaderboard and what's in the private leaderboard, because I think they said something like 75% is in the private leaderboard. So I'm expecting that when the results finally come out, there will be big readjustments in terms of the performance, especially since it's just 0.00 something. I've seen that happen in previous Kaggle competitions where the top one ended up in the 500th range.
How are you even looking at the private leaderboard? It's not available.
Yeah, it kind of says in the data set, right? The final data set.
No, the final data set is tested on 75% different data. It doesn't have to do with 75% different score.
No, 75% of the data. So it's going to be very, a lot, the private leaderboard is going to be a lot larger, right?
Oh yeah. Okay. Sorry,
So
I thought you were saying
generalize-
that the scores
there's a
were
tendency to like
varying by
focus on, like,
75%.
the performance on the public leaderboard, which is just a small subset of the entire thing. So having a good model that generalizes is a better practice than just trying to say, okay, I got a good improvement on my public leaderboard, but you're starting to like leak data into your model, and it's no longer a good, like, it might not become a good predictor. It might be a good predictor of your performance on the public data set that's being used to measure the performance on the public leaderboard, but it might not necessarily translate to a good score on the bigger data set. That's all I'm saying is, I've seen that in other Kaggle competitions where I was like looking at the public leaderboard, and then when the results came out, the gap in the jump in the performance was, they went down a lot. And I think that's because
I don't disagree with that. I'm not saying that I wouldn't say that there's not some concern for overfitting, which is, I think, is what you're talking about. What I'm saying is that I think that for the limited amount of data we have, for the number of features that we're trying to fit and the targets that we have, that this might be a case, might be a case where you could do something more open where you include more data and get a better result. And I agree 100% that I see all the time that the people on the public leaderboard don't win the competition. And generally, when you look at that, the people who get knocked a lot, you can just look at what their results were and know that they were highly overfitting. And that's where I'm saying that there's a balance between where you, like, if I was to say include everything and train for 3 times more epochs, I would expect exactly what you're saying. But if I don't look like I'm overfitting with my split data set, and I train with all the same hyperparameters, how am I overfitting with more data?
Yeah, in my understanding, like when I've read about the sort of differences that emerge in the public versus private leaderboards, usually what I see is people who have made like a whole ton of submissions over the course of the project, such that it's not even to the point where they're necessarily improving their model so much as they are just like tweaking little things here and there to triangulate the public leaderboard, the public test set. So I'm kind of agreeing with you, RK. I don't think that there's anything about retraining the model on all of the data that would lead to differences in the public versus private leaderboard, because in both cases you're still working with data that the model has never seen.
Right, and that's what I was getting at. Thank you for making that a much more palatable statement, because I don't feel like I'm doing very good.
So that would be interesting to submit according to your theory, and then submit not following that theory and compare the private leaderboard results just to see how it's gonna go, because
But as a team, you get 2 submissions, so there we go.
Well, and like I feel like I'm not gonna contribute much to this competition, so I'm willing to sacrifice like whatever score and submit separately. I know I'm not gonna win, so but
It's not about winning though. It's about learning. It's about getting through this. It's about,
yeah, but that would be good experimental design to do, A/B testing, do one with your approach and do another one without fitting all the data, and then see how it really works out.
Yeah, and I would suggest instead of, well, as an alternative, and I'm with Anya here to try out k-fold validation, something like
Yeah.
5-fold
Yeah.
or 10-fold cross validation instead of retraining on the whole data.
How do you just introduce cross validation into? Is it in the splits?
You can manually split it into 5 folds and you know, do the loop for 5 different folds. You can do it manually.
It takes 10 more trainings, depending on how many folds you have. But yeah, you basically increase the training. And another thing might be to use ensemble training. Use ensemble to combine the best results from the model.
That's true.
For different models or for?
So yeah, the idea behind ensemble is just basically mixing together all the predictions from different models. So
To
if you
stabilize
have,
them.
let's say, a 5-fold cross validation, you have 5 models. So you basically mix all of their predictions and I guess I've seen stuff where they do like rank the models and do stuff, but the easiest way to just do it is just get the means of the predictions and then use that as their submission.
I see.
Mm-hmm.
So yeah,
has
that's
anybody looked at any of the scikit-learn? Like
I have a notebook that has the 5-fold, 10-fold cross validation on tabular pandas. So I mean, it's just copying that data and trying it out. There's a lot of other stuff that you do.
I was trying to ask about if anybody had looked at random forest for doing any of the feature important stuff, because I think cross validation is pretty straightforward once you see what it is. Has anybody, to do an ensemble model, we need a different model. Like combining different neural nets with different values is not going to get you anywhere more than just getting the best neural model.
So pausing just a second, I'm just gonna like show the last changes that I made to my grid thing and stop sharing my screen, and then maybe we spend the last part talking about next steps of things to try out. Because I think that we've come up with a few different ideas over the course of both working on this and talking through this. So maybe, yeah, explicitly devoting the last part of the conversation to that would be good. So all that I have left to say is that I did run the grid again with a different architecture. And RK, I found pretty much the same as you, that this did not help. So I did one with 4 layers, 2000, 1000, 500, 300. I did generally the same parameters, and none of the minimum validation losses were as good as the best that I got from the previous architecture. But I did notice that the models needed fewer epochs. There were a lot more cases where the best value was at a lower epoch count. So like this one was set to run for 15, but it reached its best value at 8.
Yeah, and that might be where I was saying before, 12 was kind of my number of epochs, because I had changed the layers and everything. So when I ran mine, I think mine were still getting better at 12, but it was almost barely getting better at 12 compared to the training. The training was significantly better, but the validation was only slightly better.
Yeah, so I think what I'm going to do next is just take the best ones from my previous run where I had the loss in the range of like 0.0158 or something. Follow your suggestion to rerun that on all of the data and see where that gets me.
I'd like to see what you get for results there, because like I said, the single biggest change was rerunning with set values on everything.
Yeah.
Maybe we should have an internal competition.
I thought this was internal competition. Isn't this to see who gets to join the group, join the team? Because we only have 5 and there's 6 people. So
I'm out. I haven't done anything. I only submitted Daniel's code with the different parameters. That's it.
Well, you beat my score right off the bat, so.
Well, that's like, it's like gambling, right? First time you gamble, you win, and then it's downhill from there.
Yeah, so most of what we talked about so far is just tuning those different hyperparameters. So the first thing that we've kind of danced around a little bit but haven't seemed to figure out is architecture. Like, so how many layers, how many nodes? I don't know if there's any further thoughts on how we can look into that, or if that's just a try it out over the course of the week kind of thing.
From what I've seen, any more than 2 layers is too much. Any more than 1,600 nodes on the first layer doesn't get you anywhere. And obviously I haven't tried like a super grid search like what you did. I tried like manually poking at it. I think cross validation is a huge opportunity to improve. I think that is probably my next step, because I agree with what Anya and Butch are saying, that like that's best practice. So let's try that. I think retraining on the whole data, I'll give whim to, it might work. It might bite us in the ass. I would say I'd like to see somebody else's results from trying it and see if there is any difference, or maybe it was like a random seed kind of thing where I saw a huge difference, but if I ran it 15 times, it would be plus and minus what that difference was. That's the stuff I don't really know. As far as feature selection, I think should be a huge topic. Whether that be like a PCA kind of approach, or maybe like what he did in the bulldozer example, where he had the feature importance, like that could be good. I mean, anything that lets us eliminate, because there's so many features. If we can eliminate 5 features as unimportant, then that could be a huge gain.
So I am interested in that, because in a lot of my reading about deep learning versus, I don't know, conventional machine learning, one of the differences that I keep seeing highlighted is that you tend to spend a lot less time on feature engineering with deep learning, and that it sort of handles a lot of that for you in a sense.
Yeah.
So I would be interested to see if that makes a difference. I am interested in seeing what happens if you get rid of the control vehicles, because that kind of makes me think of my collaborative learning thing with the book data set, where I had all of those zeros that might have harmed the prediction. I'd be interested to see from a data engineering standpoint if that helps with anything. But I'm definitely interested to see if getting rid of some of the columns helps.
Well, and even his bulldozer example, when he got rid of those columns for the neural net, it didn't help as much as it did with the random forest, but it also reduced training time significantly. So if you're doing a grid search over this huge thing, then maybe your grid search reduces by 20% time, and your gain is 20% time rather than. So I agree with you in what you're saying, that if you have a wide, deep enough net, feature importance doesn't really matter, but it does when it comes to time.
But how are you going to determine feature importances here when we have 207 categories to predict?
Well, I mean, the same way we did in the example in chapter 9.
But there we had only one label. Here we have multi-label, which makes it, random forest makes it, I don't know how to approach it with random forest.
Well, and that's where I'm stuck. So you've hit the nail on the head, I would say. because when I'm thinking about it in a simpler term, and I don't know. That's why I'm hoping somebody can throw something in the hat that.
Yeah, actually, I was thinking for the random forest. If you think about it, it's like you have how many 200 plus items to predict whether they're 1 or 0, right?
Yeah, so
Yes.
one versus all approach.
Yeah,
Right.
so I was thinking like you have to have something like one random forest for model for each of those columns, because I'm thinking like so you have so many features, right? In the test features and the train features. So all of them are used to predict something for. So if you think about it, each column either
Yeah.
ends up 1 or 0,
Yeah.
and so you use all of the features to predict that one column.
That's
And based on
interesting.
that, you'll have like some of them might be not that important.
Right.
So you basically take them out for that feature, but then for the other features, they might be important for those. So it's like, I don't know, something
That's
like
a lot
that.
of
That
work.
was what I was thinking of using random forest. I'm not very familiar with the random forest, but that was what my initial approach was thinking that way of
So-
like looking at it as single. Each of those columns would be independent labels.
Yeah, but sorry, not to interrupt you, but looking at the notation in scikit-learn, its random forest is already set up to do multi-label
Right.
classification.
Oh, really?
So I haven't been able to figure out how to get it to work, but like it should be able to do what we're talking about doing with everything.
Yeah, there's no
Yeah, I
limit
think for
to the
go ahead.
random forests. It's just going to start breaking up the whole group into different combinations of the data based on different combinations of the input features.
Yeah, I think for me the biggest obstacle has just been, and I say obstacle, I haven't even tried it, call it a mental obstacle because it just doesn't sound fun, is setting up the data for use in scikit-learn after. I mean, I'm sure it's not even that different from what we did for Fast.ai, but it just sounds more painful and less fun than fiddling with my existing model.
Yeah.
I think input data is fine. It's the output data that in my head I don't know how to work with random forest. But if RK is saying that scikit-learn is ready for multi-label predictions, then maybe you can present next time and show me how it works, and I'll take it from there.
Yeah, no, and I mean that's pretty much where I got to in my research was
Okay.
that there was a scikit multi-class like separate package that it was scikit multi-learn is what it was called on PyPI.
Will you post it in our Slack?
Yeah, but the new version, like the new documentation, says that you don't even need that now. Like they've merged it all, where all of the algorithms that can do multi-label classification have it all built in yet, but the documentation to support it has not been done yet. So it's like what they're working on now, and so we seem kind of screwed a little bit.
Just read the source code.
Well, and I will point out, Daniel, that I think something you said hit me off on this, but when I was struggling with like some of the changing this tabular data to the multi-label stuff, there was something you had posted that hit me up to like actually go to the source code. And when you look at the source code, you're like, oh, well, here's clearly what it's doing. And like cleared everything, all of my questions up like very quickly in the Fast.ai Fast.ai library.
It's always at least worth a look.
Yeah. Yeah.
So the one other feature engineering thing that I was thinking of, I guess it's not really feature engineering, but data augmentation, really. I've seen this, there have been different competitions about like detecting fraud in different cases. And one of the issues with that is that the data sets are very imbalanced. You know, you'll have a very small proportion of fraud cases and a very large proportion of non-fraud cases. And I think some people have been applying similar logic to this problem, looking for the very rare combinations of MOAs and finding ways to perform data augmentation. I don't know what that process looks like, but just something else I wanted to get on our radar as a potential approach is kind of amplifying those rare cases as a way of maybe boosting the signal.
Well, and that was something that I had talked about last week when we originally started looking at this problem, and that there were only like 6 cases of the however many thousand cases that had 7 things that were true. And when you go through those, there's actually like 9,000 cases where it was all zeros. And I think that might be, to your point about the, what was it, CP type? Maybe those are like that CP type is a lot of those zeros. And I think there's some stuff to be done there for sure. I don't know how to deal with it, but it's food for thought for sure.
The interesting observation is the control vehicle, it actually predicted control vehicles to have actual MOAs, right? That tells me that the model is something's broken, something's not right. You know, it's something's inherently wrong with something. If it's not able to predict zero.
Well, but it's not predicting 0. It's predicting some small fraction.
Right.
And so then at the end, where you know the things are 0, you force, you know, whatever, 5, however Jeremy says it, 5 e neg 6 is so 0.
Okay, so yeah. What is actually happening with the MOAs? Are they coming out as some small number or some large number, or is it just some continuous? Should it be 0 or 1 ideally?
Yeah, I think it's 0 or 1. The outputs are 0 or 1. So it's a classification problem, multi-label.
Right. And so is that what the end?
We're required to submit a percentage.
Right.
Like
yeah,
the submission is a percentage. So it's not 0 and 1. We're not submitting 0 and 1. We're submitting 0.0001 or 0.9993.
Yeah.
Is that how they're looking? Is that how the answers are looking? Are they breaking nicely into that, or are they kind of in the middle somewhere?
No, they're all over the place from what I've seen.
Just a question.
But we're not winning either.
Yeah. There's also this extra data set called train features non-scored. There's only been, okay, so I saw this notebook that kind of used it for the neural net. Like he's trying out, I think, something like the way people are using unsupervised training to build a model, and then something like transfer learning or something. It's pretty interesting because I think what he's trying to do is he's trying to like do some kind of, oh, can my model predict this using the non-scored data, and then before using it for the final training, he kind of replaces the top layer or something. So I guess it's kind of different.
There's nothing to test against because there's no answers.
Yeah, but the thing
it's
is,
literally only the input. There's no output.
Yeah, but
I thought it was because it's the data set is trained targets non-scored. So I thought it was additional targets, like additional MOAs that you wouldn't ever use. So I don't quite understand how that would work. Like it's not additional data for training on.
Probably build a model and then replacing the top, like kind of how we use language models as the pre-training task, and then so. But the thing is, he's the only one so far that I've seen that was like using the train non-scored data, because everybody else was like not using that data set at all. So it's kind of interesting. I don't know. That might be an area.
Yeah, I'd be interested to see that. Like, just intuitively, I don't understand how that would work. Like, if you're, I don't know, just like if you're trying to like look at a picture and say like, does this have red, green, or blue? What's the value of also saying like, does it have purple and yellow and white? You know, it's like extra labels without extra data for training on.
But the idea is the neurons.
But they are targets, right?
Yeah.
They are real.
They learn something about.
They learn something. There's some intuition from those, even though they're not used in the competition. They do have some relationship to each other.
Yeah, I mean, I think that's the building of the relationship, and then you still like do the final training on the targets, but they've learned something.
Yep.
And given the sparsity of the data for the targets, it's
how
like
about for the weights? Use that for the weights.
Yeah, something like that. It's like finding the right set of weights, right? So
initialize the weights with the junk you learned from that data set.
Yeah, and then that makes a better predictor than starting from random, I guess.
Gets you started. Yeah. It gets you started.
So and he's the only one that I saw so far that was like trying to use it at all.
And what's his score?
And I guess from a domain perspective, that does
what's his score?
Areas we can explore. But yeah,
that's all this is a competition. That's interesting. I might look at that.
Okay, so to summarize so far, things that we're going to look into, we're going to keep messing with the architecture, and RK, you said no more than 2 layers, no more than 1,600 nodes. So far seems to be a good guideline.
Yeah, that's what I've seen.
Look into cross-validation and or retraining on all of the data. You've had some success with retraining on all of the data, so that seems like an easy approach to start with, at least, and then cross-validation will be a little bit more overhead to get going, but plenty of examples out there. And then some combination of feature selection, data augmentation, data removal, just messing with the data set in general. Get rid of the control cases, maybe, see if that does anything. See if there are any opportunities for data augmentation. See if we can come up with anything to do with those extra labels. See if there's anything to do with feature selection. And then lastly, see if we can get it working with scikit-learn's API in order to possibly introduce some ensembling.
But ensembling doesn't have to be with scikit-learn. It can be,
right.
You know, we can combine your best results with RK's best result, average those, and submit that.
Yeah.
Yes, that's another, yeah.
Yeah, but wouldn't it always be necessarily true that if he had some best practice that he found and I had some other best practice, that combining the approach to achieve those best practices would still be best with one model when it comes to a neural net? Because otherwise you could just add another layer of another 1,000 nodes and learn that part, right? Or am I missing something in the amount of data we have? Or I'm not sure.
Well, I think that the idea is it doesn't actually really matter what. I think it's best if you can have different kinds of models, like random forest plus neural net plus, I don't know, boost. Gradient boosting or something like that.
Yeah.
But if you don't have time, just even I think similar models. The idea is several weak learners ensembled together can become a strong learner. I think that's the idea. Okay. Whether for nets, I don't know. I'm not sure.
That makes sense. I'm just thinking like if you had infinite time.
Yeah.
I get what the ensemble gets you is like, you can have different people work separately and then just average their results and like hope for the best. Whereas what I'm thinking is more of, well, if his model has better aspects here and mine has better aspects here, and we tuned our to be one model that had the better aspects on both sides, then we would have a better model. But no, Butch, that makes sense the way you explain that.
I like your observation though, RK, though, that the neural net is a universal solver. And give it enough time, you can figure out anything. So you're thinking you could almost pull in anyone else's best practice into just another layer.
Right. Yeah.
That's probably true, given some infinite number of resources.
This competition does also allow for pulling in outside data sources, though I have not done any looking into whether there is any supplemental data out there that we could match up or use in any meaningful way.
Good
So
Lord.
you're talking about hacking some hospitals or what?
No, but I think the idea is if you do that, you need to like publish it, right? So that everybody else has access to that same data.
Yeah.
So I guess if you can search through the competition data, and if there are people who have pulled it in, they'll probably have to publish it as well. So yeah, definitely that's another area. But yeah, there's already a lot on our plate. I think just exploring
Yeah.
to add more data.
Yeah, let's get into the top 2,000.
Yeah.
Like our original goal last week, we left and we wanted to beat, I think it was 3698 spot, and we have destroyed that.
I personally just wanted to make a submission. So
Yeah, and that's great.
Yeah, no, it's really good. It's
I
really
was
good.
happy to copy a submission.
And you just hit Control Enter, Shift Enter, Shift Enter. That was fantastic.
The nice thing about this is actually that it runs pretty fast, because
Yeah,
the thing I hated about a lot of the other competitions I've joined was like they took so long, and then you get like not that good results. So it was like, man, I spent all that time waiting
but
for
that
it.
was the thing with the tabular data. Even though there's a significant amount of rows, there's a significant amount of features, there's a significant amount of targets. It's such simple data when you compare it to image data, right? That has RGB, channels, point of data. Like it makes sense.
Oh, you're cutting out, RK.
Oh no. Okay, you got me now?
Yeah, you're there.
I was just saying that the way the data is laid out, it's
Pretty.
tabular data.
Yeah.
It's simple compared to image data that has, for every pixel, has RGB channels. That you're trying to take.
Yeah.
It's much more simple.
I get the feeling, my intuition is that probably I'd hope we'd meet after the competition completes and see the results, because my intuition is that the guy who wins, or the person who wins, will probably be using deep learning plus some other thing that's not deep learning. That my intuition is that the person who will win this will probably say, yeah, I use deep learning plus
some feature selection, some tricky feature
some other technique, either
Some embeddings. I bet it's gonna be embeddings.
But the thing is, yeah, actually I was thinking of embeddings, but there's not a lot of categorical data here. So embeddings might not help.
Yeah, it's only 3 channels of categorical.
Yeah.
But
The thing is maybe something like some weird stuff where they like build a neural model and feed that output into some other model. I remember Jeremy suggesting this thing where he said, oh, people do use like generate neural nets or to generate embeddings or some sort of activations, and then use that for something like random forest or stuff. It's kind of at the end. I think he kind of mentioned it on the tabular, but that's interesting to combine, because I definitely know that for tabular data, deep neural nets are not yet the top of the not like computer vision, where if you have a computer vision and you're not using deep learning, you'll probably get worse results, right? Right now, for computer vision, everybody's like using deep learning. So, but for tabular data, that's not true.
But the problem with the tabular data, at least for what I do for work, is if you're not a subject matter expert, it's really difficult to decipher that tabular data into the machine learning stuff. If you're a subject matter expert, then sure, it's fine. It's like, you know, I know all this stuff, so I'm going to do those things. So I think for us, one, we're doing a deep learning course, not a machine learning course, and two, that none of us really even know what the hell we're studying in this particular competition. I think deep learning and trying to get as best we can with deep learning is a valid means. I think ensembling, what you suggested is like, that's going to get us in the 2000s. If we can get a random forest to solve this problem and use those averages, then that's going to get us up there.
Will you be happy if we get under 2000?
If we get under 2000, I'll be happy.
All right. Yeah.
I mean, I got under 2700 today, and I was happy. So,
So I like the thought that CNNs do well because there's a spatial relationship between the input features, and that's what they do. CNNs just deal spatially with things. We don't know what the relationship is between these features. These are what, gene sequences? What are the, that's the point. We don't know what they are, but they're something. They represent.
Yeah, I think the tabular model is an ANN, not a CNN, but I might be wrong.
Yeah.
So isn't it fully connected?
No. Well, my point is, CNNs do good on vision because the features are spatially related. They're pixels. They're neighbors. Right. There's a connection. The CNNs do things with the neighbors and all that. There's a deep relationship between the features spatially. These features have little to do with each other that we know of, that we're not taking advantage of.
Right.
Because we don't know. Like, what are those numbers? I'm looking at G12, 0.3. What's 0.3 of G12? What's a G12?
Yeah, actually, that's a good point, that we're not domain experts. But the other thing, and it's because I don't have a data science background. I'm more of a software developer. So the thing that I'd like to learn really is probably more like the analysis of the data even from a data scientist, not necessarily a subject matters expert, like figuring out the data imbalance, the sparsity of the data, correlation of the columns, that kind of stuff is a skill that I'm not very good at. And I'll probably take a look at other notebooks to see if they do that, because even though I think from one aspect, even the data scientists might not be subject matter experts, but they are experts in analyzing that data and figuring out relationships between the features and coming up with plausible optimizations that they can do to get better results. That's the area that I'm I wish I had a stronger skill set in that, in probably learning about pandas and scikit-learn and stuff.
Yeah, that's a good thought, actually. I think the normalization, you just chose normalization for the heck of it. Maybe there's a distribution. Maybe there's a distribution.
Are there parameters to do that on and stuff like that?
Yeah, I mean, what if there's a better distribution, a better normalization technique?
Exactly.
Yeah, I think that's a great point. That's
'Cause-
I did a machine learning project for a class a few years ago on a genetic data set, and we were getting pretty mediocre results at first, and then read a couple of papers on the actual data, and one of the papers talked about some particular but very simple method of normalization that they used on all of the data, and after we applied that, the results were just wildly better.
Right.
Well, and I think when we were talking about feature engineering, like I've kind of been thinking about it from a standpoint of what he did in the book, where he used the random forest to do feature importance, but he didn't go through the PCA type approach where you're just looking at this correlation of like what puts the biggest spread in the data.
Right.
And it, maybe that's even a simpler approach to say, okay, here's all my truths. Like what I think Butch was saying, like what if you just took each column and said, okay, for each column that's true, what is the cross correlation of the different features to that one feature, and try to recognize what are the biggest features that predict that target's value.
We are down to the last few minutes, so before we go down another rabbit hole, just gonna say that this is time for closing thoughts before we call the meeting, and then we can keep discussing through the week on Slack.
I think I've said enough.
But this is great. I think that we've made a ton of progress just in the last week, and I'm excited to see what some of these avenues for improvement lead us to.
I agree. Are you going to publish the notes you took?
Yeah, the grid search or just the notes of this
Like
conversation.
the discussion part.
Yeah, I can. Yeah, I'll at least throw it on Slack. Just
I
the.
just paste it up or whatever. So
Yeah.
we're at least all kind of, in 2 days we look back at it. I'm actually on vacation this week, so it's like, well, that's called raising a almost 3-year-old, but
how's our Slack channel? Is it going away pretty soon? Because it was supposed to disappear, right?
I haven't heard anything. Not that I would hear anything. But hopefully at some point in the next week we can figure out from Andy what his plans are going forward, if he wants to stay involved, or if not, how to whether we want to keep going on the same platform or transition to something else, or what we want to do.
Okay, because if we transition, we lose all the nodes, correct?
Yeah, but I mean, I think that we can pull the important things if we need to.
Okay.